Hello, in this presentation, I will give a short introduction to regression splines with R package splines2. First of all, what are splines? Splines are important tools for flexible modeling of curves and surface in regression analysis. It has wide applications, including shape constraint regression, generalized additive models, single index model, and so on. Mathematically, splines are piecewise polynomials that are continuous and differentiable up to a certain degree at a sequence of breakpoints called knots. A spline function is a linear combination of spline basis functions. There's a variety of representation of flavor of basis function, including generalized Bornstein polynomials, p-splines, m-splines, i-splines, convex spline named c-splines, and so on. Due to the time limits, we're not going to cover each one of them in details. Now let's look at the package itself. The package was named after the package splines included in base R. It was designed to be a supplemental package to splines package. And one may install the release version of splines2 package from Cry by the install package function. The developed version is available at GitHub and can be installed with help of the remotes or DevTools package. The splines2 package provides main functions to construct basis matrix of b-spline, m-spline, i-spline, convex spline named c-splines, periodic m-spline, natural cubic splines, generalized Bornstein polynomials, and their integrals and the of given order by using closed form recursive formulas. In addition, the package includes a C++ head-only library that allows construction of those spline basis matrix directly in C++ with the help of the RCPP package. So now let's look at the R interface. The R interface was designed to be very similar and consistent with the function BS in the splines package of base R. The BS function in the splines package contains arguments x, df, knots, degree, intercept, and boundary knots. By using this consistent interface, there will be no unnecessary learning curve for those users who are familiar with the splines package, in particular the BS function. Table 1 summarizes the arguments of those main functions in the splines2 package compared to the splines BS function. We found that for most of those functions, it may include one additional or two additional arguments for derivative of the basis function or integral of those basis function. In particular, for m-spline function, it contains one argument called a periodic, which takes logic vector of logic value true or false. If true, then it will return the periodic m-spline basis. The package provides several S3 methods for the object returned by the main functions. The first S3 method is called derive. It gives us the derivatives of each basis function. Second S3 method is predict. It can be helpful when we want to evaluate the basis function at any new given x. And the third method is called knots. It helps us to extract the place internal or boundary knots for the returned object. The last method is print. It just simply print out the basis matrix in a clean format. Compared to the splines package, the package splines2 provides more spline basis functions, as we have seen. What's more, the function b-spline in the splines2 package extends the BS function in splines package by allowing basis function of degree 0 or piecewise constant basis. which seems to be trivial. However, it's useful for some applications. The function natural splines in the splines2 package returns a non-negative basis of a function within boundary for natural cubic splines by utilizing the closed form null space. However, the NS function in the splines package use the QR decomposition to find the null space, which is less computationally efficient, as we will see later. Now let's look at a micro benchmark for comparison, for reference. We compare for each particular spline basis. We compare the available implementation. In the first, for B spline Bornstein polynomial and the derivative of B spline, we compare the function We compare with the package splines. And when we found that splines2, the implementation in splines2 package can be slightly more efficient. Similarly, we compared those implementation provided by other package available on Chrome as well, and we may find that splines2 package provides more computationally efficient routines than those package. As I mentioned, the package also provides RCPP interface. It's mainly intended for our package developer who would like to use a splines2 package at C++ level. The implementation used Armadillo library with the help of the RCPP Armadillo package. Now let's look at one particular application of the splines2 package to shape constraint regression. In many applications, subject matter information is available, and the regression function is known to satisfy various shape constraints such as non-negativity, monotonicity, and convexity. For example, the dose response curve in the phase 1 clinical trials may require the non-decreasing dose response curve. Also for growth curve of animal and plants in ecology, or for the hazard rate in survival analysis, the hazard rate function should be non-negative. So in general, we can consider a regression model yi equals xi plus epsilon. If we assume f to satisfy a given set of shape constraints, but not necessarily based on a specific parametric form, we can do a non-parametric regression by using to resolve the shape constraint regression problem. We apply the I-spline and SIP-spline to the age income data, which is example data in this book and this paper. We consider a non-decreasing and the convex relationship between the age of the workers and the expected logarithm of the income, respectively. Now let's look at the result. This figure gives us visualize the fitted non-decreasing curve by using I-splines with different degree of freedom. We also included a smoothing spline for comparison. We may find that the fitted curve by I-spline are all non-decreasing, are close to each other. And for the smoothing spline, the tuning parameter was selected by GCV criterion. Similarly, we fitted a convex curve by using C-splines. Again, they are close to each other. Those C-spline bases with different degree of freedom are close to each other, and the fitted curve are indeed convex. So the robustness of the fitted curve in terms of the degree of freedom make it possible to draw statistical inference. If you want to learn more about the splines2 package, you may go to the package homepage or visit the GitHub repo. Thanks.